objects. Y'all tuned me out. I don't understand what's happening today. Bagels. Good. My bagels are distinct. So how many do I have? No, those are my balls. My balls will consist of bagels. So let me rephrase that. How many types of bagels do I have? I have 5. Good. Those are my distinct objects. Or my urns. Okay? That's going to be true in all types of our problems. So this doesn't tell me that this is an order, doesn't matter, repetition is allowed. But what is true is if I want to be able to, so what are our key things here? We want to select a bunch of bagels, which I can have more than one Asiago, right? I could have 10 Asiagos or 4 Asiagos. I'm just trying to figure out how I get 12 bagels from this 5. So knowing that, let me even write this down. Just because I know sometimes it's hard to know by the words. So since I can have more than one type of a bagel, what does that tell me? So if I place a ball in an urn, and I can place more than one ball in an urn, then I'm saying repetition is allowed. Good. Repetition is allowed. Now, if I have 2 Asiago bagels in a bag, I shake them up or I move them around, is it any different? No. So what does that tell me? Are my balls distinguishable or not? They are indistinguishable balls. Which means order doesn't matter. Bagel 1, Asiago bagel 1 and Asiago bagel 2, whatever order I have them in my bag, it's still 2 Asiago bagels. So order doesn't matter. Okay, so this tells me it's that 4th case. Order doesn't matter, repetition is allowed. All right, so what's the answer here? So since n equals 5, this means I have how many bars? Since r is equal to 12, this means I have 12 balls. All right, knowing that and knowing what type of problem this is, we should have all the tools to count the number of ways we can distribute these 12 bagels into these 5 categories. And what would be your final answer? I'm going to need a lifeline. Did y'all watch that show ever? Okay, 16. Let me write it out in an obnoxious way. It's going to be 5 minus 1 plus 12, which is indeed 16, factorial over 5 minus 1 factorial, which is 4, and 12 factorial. Perfect. Okay. How about B? So it might seem like a hard problem, but it's really the same problem with one slight adjustment. Any ideas? I'm still going to write my bagels. No, repetition is still allowed. So we have, what do we have? We have Asiago, plain, wheat, cinnamon, salt. So we still have the 4 bars. Not only will each N necessarily be non-empty, I've really just removed those. I mean, that's already done. Those are indistinguishable balls, yes. And so what's really the question is wait, those 5 are taken. The real question is how many ways are there? There's only one way to put one bagel in each one, right? So how many ways are there to distribute the other 7 into these bins? And it's the same problem. So I still have N minus 1 equals 4 bars, but this time I have only 7 balls because 5 are already accounted for. That makes sense? So I would have 4 plus 7 factorial over 4 factorial, 7 factorial. All right, C, what if, same question, she selects at least 2 of each. Yep, same number of bars. This time, R is 2. Yes, we only have, the 10 of them are already accounted for. Where do the other 2 go? So 4 plus 2, 4 factorial, 2 factorial. Okay. And we're going to reframe those 4 questions I just asked in terms of, we're going to rephrase them all in terms of urns and balls. So remember, your urns are your N distinct objects. And all 4 of these problems, those exist. There's obviously other ways to count, as we saw, but in these 4 problems, our urns are our distinct, is the thing that's distinct in all problems. The balls are, there's 2 things to consider. Are they distinguishable? And that deals with order. And I'm going to say, is repetition allowed? So it's the balls you have to address those questions to. All right. So if we look at, so if an urn can hold only 1 ball or at most 1 ball, repetition is not allowed. And are the balls distinguishable? Balls with different numbers on, or are they all blue balls? All right. So if they're all the same, indistinguishable. If they have numbers on them like lottery balls, those are distinguishable, right? So that's one way to think about it. So let's look at those 4 questions above. In how many ways can those 4 board members out of the 26 members, those are my urns, and since they have those different names, well, if the urn can only have 1, then that means repetition is not allowed. An urn can hold at most 1 ball. So that means repetition not allowed. And then it can hold at many balls. That tells me repetition is allowed. Distinguishable tells me order matters. indistinguishable. I don't know how I'm spelling this. Indistinguishable. Order, no matter. So my 26 members in all cases are my urns. Now the slots, so the 4 delegation slots, remember I didn't give them a name. They weren't president, vice president. So they were indistinguishable balls. So there's my 4 balls. They are indistinguishable. Nobody can repeat jobs, remember that. So it was with exclusion, no repetition. Or, and how many ways can 4 different jobs, so my balls are distinguishable, can be distributed among my urns. And a member can do more than one job. So here we're saying repetition is allowed. Order matters. Repetition allowed.
Good kitties.
And over here, how many ways can 4 identical jobs, indistinguishable, order no matter, to my 26 urns, without exclusion. So repetition is allowed. So this is that last case. Order doesn't matter, repetition allowed. So that's one way to think about these 4